Hey guys, here is our lesson on exponential and log equations. And here's what I've done. I've literally copied the exact problems from the book and circled some that I'm going to do for us. So you'll see 8 and 10 here. I've circled a few in here, and so on and so forth. So I'm just going to go through and solve these, and so you'll see how to do almost every single one of the problems before we're done. So first problem is number 8, and that says 625 times 5 to the 3x plus 3 equals 125. Now here's what we're going for in all of these problems. What is true is this, that if you knew that a to the x equaled a to the y, the only way that can be true is if x equals y. And so I'm trying to get the base. Notice if the base is the same, but I believe that the powers are different, but somehow these two are equal to each other, that can't happen. Those two powers are the same. And the reason that that's true is because of the graph of an exponential function. So a graph of an exponential function, for any value, there is only one number that will hit it. And so if I said that I've got like 2 to the x and 2 to the y, well, 2 to the x would, if this was the graph of 2 to the x, then this would be whatever x is 2 to the x, and if this was 2 to the y, they would be on different lines. And so if they were equal, meaning they were the same height, the only way that could happen is if those powers were in fact equal. And so that's where that comes from. So what I'm going for in all of these problems then is trying to get the bases the same. So taking a look at this problem here, I see that I have a base of 5 in here. And so I'm wondering, is 625 a power of 5? And is 125 a power of 5? Turns out that yes, they are. Turns out that 5 to the third power is 125, and 5 to the fourth power is 625. And so, using that, I'm going to say then that we have 5 to the fourth power times 5 to the 3x plus 3 equals 5 to the third power. Now what I have here, and this is where we need properties of exponents. You know, when you have the same base and you have exponents there and you're multiplying them, you add the exponents. The rule that you always see is a to the n times a to the m equals a to the n plus m. So this side becomes 5 to the 4 plus 3x plus 3 equals 5 to the 3. Now all I'm going to do is simplify here. So the 4 and the 3 make 7. So I've got 5 to the 3x plus 7 equals 5 cubed. And now, as I had in the beginning, that a to the x equals a to the y, if and only if x equals y, I have my a here and my a here. There's my x and there's my y. So now I'm going to set those equal. So 3x plus 7 should equal 3. Take away 7 from both sides. I get 3x is negative 4. And so x is negative 4/3. Here's something kind of cool about that. And I'll show you right here. If I take negative 4 divided by 3 and put it in the calculator, now that's my answer. So that's the answer that I believe to be true right down here. Now what I'm going to do is plug it in up here, and I'm going to type it exactly as it appears right here. So I'm going to say 625 times 5 raised to the... Up top, it's 3 times x. That should be exactly this right here, where instead of the x right there, I've used answer, but the answer is the previous one, the negative 4/3. When I hit enter, it should say 125, and it does. So there I have verified that that is the correct answer. All right, then the next problem. So in that one, we have 1 over 64 to the 3n times 8 equals 2 to the 6th power. And on this one, at first, I would think maybe I want to use a base of 8 because there I have, that's 8 squared and that's 8 to the 1. But over here, the base is already 2, which is smaller than this. And I know that 8 is 2 cubed, and I know that 64 is 2 to the 6th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 60, or 32, times 2 is 64. There's 1, 2, 3, 4, 5, 6. So 6 2's make 64. So I'm going to turn this into 2's. And so I'm going to say 1 over 2 to the 6th to the 3n times 2 cubed equals 2 to the 6th power. Now, I know that if I have an exponent on bottom and I bring it up to the numerator, I have to change the sign of that. And so I'm going to say 2 to the negative 6 to the 3n times 2 cubed equals 2 to the 6th. Now I have a power to a power, and when you have a to the n to the m, that's a to the n times m, you multiply. And so I'm going to multiply those two powers there, and say we have 2 to the negative 18n times 2 cubed equals 2 to the 6th. I'm going to come up over here now, so rotate the page. Now I have same bases on this side, a base of 2 and a base of 2 to exponents, and it's multiplied. So I need to add those exponents. So now I have 2 to the negative 18n plus 3 equals 2 to the 6th. So notice the whole time I've just been limping that 2 to the 6th along, and it's even there in the end. But all my work was manipulating and massaging that left-hand side to where I can make it a single base. Because now I have my base there and the same base there. They are to seemingly different powers like that. The only way that can be true is if negative 18n plus 3 equals 6. In solving this, take away 3 from both sides, you get negative 18n equals 3. Divide, and you get negative 3/18, which reduces to negative 1/6. And so I can do the exact same thing in the calculator on this problem. I'm going to put negative 1 divided by 6 and enter that in the calculator. So that was my previous answer right here. And now I'm going to put this in over here. So I've got parentheses, 1 divided by 64, parentheses, raised to the, it's 3 times n. 3 times n is my answer, and so I'm going to use the answer for that. And then that's times 8. Okay, now I've done that whole side, and when I hit enter, I get 64. So that side comes out 64. 2 to the 6th power is 64 on that side. 64 equals 64. That checks out. And so there again, I have verified that that's the correct answer. All right, I'm going to cut this off, and I will upload it and make another video of the next section. Take care, guys. Bye-bye.